Example 4. Find the critical numbers and intervals where the function is increasing and decreasing. Well, first of all, let's notice that the domain of this original function is negative infinity to positive infinity. There are no excluded values because there are no square roots and there are no denominators. If it's a square root, we can't have a negative, and if it's a denominator, it can't be 0. But in this case, we have neither. So to find our critical numbers, we find f prime of x and set it equal to 0. So our f prime of x is 2.8 minus 1.8x. So this is a constant, so that was 0, and this is a coefficient, so it's 2.8, and here I use the power rule, 2 times negative 0.9, and decrease that by 1 to get the 1.8x. Now the next thing we do is we set this expression for the derivative equal to 0. And then we solve. So I'm going to subtract 2.8 from both sides. That's going to give me negative 1.8x equals negative 2.8. I'll divide both sides by negative 1.8. These will divide to 1. Here we'll have a negative divided by a negative, which is a positive. I can move the decimals both to the end, 28 over 18. And then I can divide both of those by 2 to get 14 over 9. This is my critical number. Now in this case, I only have one critical number. I will put my critical number on a number line, 14 over 9, and I've got to pick a number to the left, such as 0. This is going to be my t or test point on this side. And to the right of that, you need to know what 14 divided by 9 is. It's about 1.555 repeated. So I need to pick something bigger than 1.555, so I'll pick a 2. That's my t number 2. So these are both test points. And I need to test both of those in the derivative. So the first one I'll test is f prime of 0. That's going to be 2.8 minus 1.8 times 0, and that's going to give me 2.8. Now, since f prime of 0 is a positive, that means that everything in this interval to the left of 14/9 is positive. And remember, it keeps going this way to the left, to negative infinity. So we've got a positive here. Now I'm going to check f prime of 2. So that's going to be 2.8 minus 1.8 times 2. That's going to be 2.8 minus 3.6, and that's going to be negative 0.8. So this is a negative. Now that means all of the values in this second region on the right side of 14.8 are negative. So the derivative f prime of x is greater than 0 here, and f prime of x is less than 0 here. So let's talk about what that tells us. When f prime of x is less than 0, that means the slope of the tangent is negative. And that means the function has to be decreasing. Function is decreasing. So, for example, if I just draw a parabola like this, and you'll see that it reaches its low point here at this vertex, okay? And you'll notice that it's rising here, and if I were to draw tangent lines to any particular point, notice what's happening to these tangent lines. They're all going uphill. Those are lines with positive slopes. So when the tangent lines are looking like this, you know your function is increasing. However, if we look on this other side, if I were to draw a tangent line, say to right here, that would be a line with a negative slope. So when f prime of x, the tangent slope, is less than 0, it's decreasing. But if f prime of x is greater than 0, that means the slope of the tangent is positive. And that would mean that the function is increasing. Now that brings us to one other point that we'll do in the next section, but do notice here that at the vertex point, this tangent line is horizontal. This is where the slope is 0, so f prime of x is equal to 0. And what we will learn is that this will tell us where we have our extreme values, our minimums and maximums. And that is what we'll cover in the next section. Okay, but for now, we just need to remember that if the derivative is negative, that means the function is falling or decreasing, and that if the derivative is positive, the function is rising or increasing. And so we can now say that f of x is increasing from negative infinity to 14/9, and that f of x is decreasing from 14/9 to positive infinity. And that is our final answer for example number 4. And don't forget that this 14/9 was our critical number. Example 5. Find the critical numbers and intervals where the function is increasing and decreasing, where f of x is 4/3 x to the third minus 2x squared minus 168x minus 32. The first thing I will do is take my derivative, and I get 3 times 4/3 x squared minus 2 times 2x minus 168, and of course the derivative of that is 0. So I get 4x squared minus 4x minus 168, and that is a quadratic equation. So when I set it equal to 0, I will most likely get 2 unique solutions. And so I notice that each of these terms has a common factor of 4, and as long as I divide all terms on both sides, I can do that. So I'll get x squared minus x minus 42 equals 0. So I have 2 choices here. I can factor, or I can use the quadratic formula. And I always recommend factoring if possible. And in most cases, it's going to be possible in this class. So if you want to use the quadratic formula, you can go back and YouTube that and do that, or try to learn to factor. The factors of negative 42 that will give me a negative 1, it's got to multiply to negative 42 and add to negative 1. So I know I'm going to need a positive and a negative. And I always start with negative 1, negative 2 times 21, negative 3 times 14, negative 4 won't go evenly, 5 won't go, 6 times 7, 7 times 6, and you see they start to repeat, but the signs are switched. And I can stop here because these are the numbers I need. I've got x minus 7 and x plus 6 will FOIL out to give me that trinomial. So I set the first one equal to 0, so x is 7, and the second one equal to 0, so x is negative 6. Now, to be critical numbers, they have to be in the domain of the original function, and this function's domain is negative infinity to positive infinity because there are no square roots and there are no denominators. So these two numbers are our critical numbers. Now we have to take our critical numbers and put them on a number line and test them in the derivative. So now we take our critical numbers and we place them on a number line. This time there are 2, and be sure you put the smaller one to the left and the larger one to the right. Now this time our number line is divided into 3 intervals, from negative infinity to negative 6, because this keeps going, between negative 6 and 7, and then from 7 to infinity, because this keeps going. So I've got to pick my t values in 3 different intervals. So I'll pick t is negative 10 for the first interval, t is 0 for the second interval, and t is 10 for the interval on the right, and I've got to test them in this derivative. So whenever I put in a negative number, I need to put parentheses around it. So negative 10 squared minus negative 10 minus 42. So that's going to give me 100 plus 10 minus 42. 110 minus 42 is positive. Now, it's irrelevant the actual value. What you want to know is the sign. So you don't even have to take the time to subtract 110 minus 42. Just determine the sign. So this left interval is a positive. So we'll come back in a minute and make our conclusions. My next test point is 0. So 0 squared minus 0 minus 42 is 0 minus 0 minus 42, and that's going to be a negative. So in this middle interval, my derivative is negative. And on the right, I'll check 10, that's my test point, 10 squared minus 10 minus 42, that's 100 minus 52, and that is also a positive number. So this region is positive. So our final answer will be, these are our critical numbers, and this function increases on the positive intervals So that's from negative infinity to negative 6, and separated with a comma, 7 to infinity. It's decreasing on that interval where it is negative, so it's decreasing from negative 6 to 7. And don't forget, you're always using parentheses or open intervals when you describe increasing and decreasing.